This is the Unit 5 preview video and notes for Introduction to Congruent Triangles. You should be taking a look at these notes here. Please remember to get your name on here as well as the location that you are watching these and the date and time. You also need a parent or guardian or teacher sign-off. Let's review where we've been. In a previous unit we talked about similarity, which are items that have the same shape or different size. I'd like you to look at the triangles below and determine if the triangles are similar, same shape, different size, and determine the shortcut side, 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 side angle, side, or angle, angle similarity. Let's observe what we have, closely observe. We notice first off that we have a pair of congruent triangles, so sweep those, hatch, and put an A for congruent triangles. Now let's check the side ratios. 16 and 24 are both divisible by 8. If we divide 16 by 8, we get 2. 24 divided by 8, we get 3. So we have a 2 to 3 ratio. Over here we have 24 and 36. Both of those are divisible by 12. If we divide that by 12, we get 2. Divide this by 12, we get 3. A 2 to 3 ratio. Notice the ratios are the same. So if these ratios are the same, we put an S for the side ratios being equal and another S. So we see that these triangles are similar by side angle side similarity. So now we're going to switch from triangle similarity to triangle congruency. Here's some key words you need for this lesson. Side, 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 congruency. Side, angle, side, congruency. Angle, side, angle, congruency. Angle, angle, side, congruency. The concept of similarity and scare. Should also have a pencil and colors handy. First off, what have we learned so far? Let's recap. We have learned that triangles that are similar have the same shape but they have a different size. That is similar. So I'm going to put that similarity sign there. Triangles which have the same shape but a different size. They are similar. Same shape, different size. But now we're going to talk about triangles which are congruent. There's a difference here. Box the word similar, box the word congruent. We're going to talk about the main difference here. The main difference being congruent triangles are triangles which have the same shape and the same size. Same shape and the same size. They are congruent, which means exactly the same. The symbol we use here is a congruent symbol, not a similarity symbol. Make note of the difference. That's a similarity, same shape, different size. That's congruent, same shape, same size. So the rest of the lesson is going to be about congruent triangles. Now, congruent triangles are created when you take a triangle and you move it. There's 3 main motions. Now, you can combine motions, but the 3 main motions are this. I'd like you to trace this triangle with me. Just trace it. Now slide, and then we recreate another triangle. That's a slide. That slide is called translation. Now I'd like you to trace this triangle, and then imagine flipping it over to the other side, flipping so that you get a mirrored image. Imagine flipping it over something onto the other side. That's called reflection. Now trace this triangle. Now imagine if your finger was right here and you were to pivot the triangle and turn it. The turning, that is called rotation. So the three motions that you need to be familiar with are translation, reflection, rotation. Translation, reflection, and rotation. What I'd like you to do is take 1 minute, or actually more like 30 seconds. I'd like you to name the motions that you see 1 through 6. Name the motions that you see, translation, reflection, or rotation. I'll give you 30 seconds. It shouldn't take more than that. Okay, taking a look here. Number 1, that is a mirrored image, so that is a reflection. 2 is a rotation. 3 is a reflection. 4 is a slide, so it is a translation. Look very carefully. Number 5 is a reflection. And number 6 is also a translation. Now let's see how this relates to triangles. These motions are related to triangles. When you take a triangle and you put it through one of those 3 motions, you're going to create congruent triangles. For example, we have this triangle over here on the left. Triangle BCD. B, trace with me, C, D. And then we have this RST, so R, S, T. You want to ask yourself, what is the motion that if we took that green triangle and we moved it, how did we move it to get the purple triangle? Take about 10 seconds. You try to fill that out before I fill that out. Which motion moved the triangle from the green to the purple? Translation, reflection, or rotation? Okay, you should note here, do you notice D and T are in the same position? And to get D and T in the same position, we had to rotate. Rotate. Or we could take this and bring it back down. So either way, this is a rotation. And when a triangle's been put through that motion, there's a total of 6 items congruent. 6. We see here that angle B is congruent to angle R, and angle C is congruent to angle S, and angle D is congruent, notice the 3 hatch marks, to angle T. We also note that B to C, so watch the order here, from single swipe to double swipe. B to C is the same, single to double, as R to S. You must go in that order. Because here we went from single to double. Here you must go single to double. We also know that the side CD, so C to D, double to triple, is congruent to S to T, double to triple. Last one, DB, that's triple back to single, is the same as T to R. Notice the 3 hatch marks. So when you take a triangle and you put it through the motions, either translation, rotation, reflection, you end up with 6 pairs of items which are congruent. We have 3 pairs of angles, and we have 3 pairs of congruent sides. 3 pairs. And 3 pairs, a total of 6. So you must correspond the congruent vertices. I'm going to give you an example here. First, you want to ask yourself, what is the motion of the triangle from the left to the right? What was the motion? Think about it. Is it a slide? Is it a flip? Or is it a rotation? The key thing here is you want to look at corresponding vertices. And we see W goes with N. Now that looks like a reflection. But if you were to reflect this, this W would go over to this way. So it's not a reflection. We know that to get from that W to that N, you'd have to rotate. So it is a rotation. Now you must also, after naming the motion, you must carefully align the vertices. So watch very carefully, because you're going to have to do this in just a moment. We see here that we're going to start with M, L, W. So we go M, L, W. And M is a single sweep here. L is double sweep. And then W is triple sweep. And we want to go that exact same order. So to go that exact same order on the other side, watch carefully, we must start with the single sweep. Then we have to go to the double sweep. Then we go to the triple sweep. So we must go in this order. L, M, W, and back around. Excuse me, L, M, N. And in this case, that would be single sweep, double sweep, triple sweep. So you have to align your vertices when we're dealing with congruent triangles. Notice the hatch marks. Let me see if you understand this. I'd like you to take a shot at this one. Identify the motion from the left triangle to the right. Identify the motion, then align the vertices. I'm going to give you 30 seconds. All right, so first off, the motion here is a reflection, like a mirrored reflection. So that's the first thing you need to be familiar with, is that we have a mirrored reflection. And we want to correspond triangle RQE. So RQE. Watch those hatch marks. That's single sweep. In this case, Q is double sweep, and then E is triple sweep. So you must go in that order. So looking at this other triangle, the single sweep is going to be R, the double sweep is going to be Q, and then the triple sweep here is going to be P. Hopefully you did that correctly. So what we're noticing here, I'm going to teach you something real simple. If I say here the whole triangle is congruent, so I have the left triangle is congruent to the right triangle, then I can say all the corresponding parts are congruent. In other words, the angles are congruent, the sides are equal, each individual part are congruent. So we write, if the whole triangles are congruent, then the parts are congruent. We'll do more of this in class, but there's an acronym for that, and I don't want you to be intimidated by this acronym. Just write this down. I'm going to say it as I write it several times. The acronym is CPCTC. CPCTC. It stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. The simple way of explaining this, if we say that you have two hands are equal, then all the individual corresponding fingers and parts are equal. The hands are equal, the parts are equal. Let's put this to application. We're going to be talking about congruent parts, and there's three what are called freebie congruent parts. Congruency freebies. That means things you can mark congruent even if they're not marked congruent. There's three of them. You need to be familiar with them. One would be something called vertical angles, and you guys know this. If you see angles that are vertical, like so, you should hatch, and put an A for congruent angles. Another freebie, draw in straight down a side here. So now technically we have two triangles. We have the yellow and the green triangle. The yellow and green triangle exactly share this side, exactly share it. That's called a reflexive side. If you see it, you should hatch it and put an S for side because it's a shared side. It's a congruent side. It's called a reflexive side. Here, you should also watch out for, here we have a red triangle, and then trace with me the blue triangle. Trace the red and the blue, please. Both the red and the blue exactly overlap and share this angle. That's called a reflexive angle. Hatch mark and put an A for congruent angles. So every time we have a pair of congruent angles, we put an A. Every time we have a pair of congruent sides, put an S. And there's three things that you should watch out for: vertical angles, reflexive sides, and reflexive angles. Let me give you a demonstration. Down below, we're going to mark the freebies. Trace and mark these with me. In the first, we have here from A to B, trace that. A to B is a side that's shared by both the left triangle and the right triangle. It's exactly shared. So we're going to put a hatch mark and put an S for a pair of sides. In this diagram, we actually have overlapping triangles. Why don't you trace them? There's the red and the blue. We have overlapping triangles. Now I'd like you to sweep the toe there, the toe angle, hatch, put an A. That's called a reflexive angle. It's an angle that's exactly shared by two triangles. It's congruent. Another source of course, is vertical angles. If you see them, you should mark them and put an A for congruent angles. Let me give you some more examples. So here in this first one, we have a reflexive side. Trace it, hatch mark, S for a reflexive side. Second one, we have another set of reflexive sides, a side that's completely shared. We trace it, hatch it, put S for congruent sides. In this one, you see we have vertical angles or bow tie angles, hatch mark, put A for a pair of congruent angles. Here, there's your blue, trace it, and your HKJ, trace it. They both overlap at that angle, hatch mark, put an A for congruent angles. Those are freebies. Now notice we have other things pre-marked congruent here, for example, these pair of sides. So go over those, hatch mark, put an S. Go over these, that's an A. Here we have a pair of angles. For each pair, put an angle A. Here we have another pair of angles, put an angle A. Here we have a pair of congruent sides, we're going to put an S, and we have another pair of congruent angles, put an A. One S for one pair of sides, one A for a pair of angles. Here there's nothing else that's congruent. So what I first marked were freebies, the other markings were givens. So for these two problems, problems 1 and 2, I'm going to give you 2 minutes to work on your own. And in 2 minutes, we'll come back. Let's see what we have here. First off, what is the motion? And the motion here is a type of rotation. We take the S and we rotate it upward. So it is a rotation. Taking a look here, we have K, which is right here, and its match is going to be T. And then we have S, which in this one is double. So over here we go double, U. And then we have I, which is triple, and down here S is the triple. So there's your match there. So KSI, let's trace it, KSI is the same as TUS. And if you trace that, you'll feel that they are the same. Taking a look at this page, mark the freebies. So here, the freebie would be the vertical angles. A. Here, reflexive side. S. Here, vertical angles. A. Here, another reflexive side. Hatch mark. S. Here, a reflexive side. Hatch mark S. And here, a reflexive side. Hatch mark S. So to review, when we have congruent angles, when triangles are congruent, we have a total of 6 items which are congruent. 3 sets of congruent sides and 3 sets of congruent angles. A total of 6 pairs. However, just like in similarity there are shortcuts to congruency. The first one is called side-side-side shortcut, and that is if we have 3 pairs of congruent sides. So hatch mark, put an S, double hatch mark, put an S, triple hatch mark, put an S. If you have 3 pairs of congruent sides, then the triangles are congruent. Let me give you an example. Look down here. Hatch mark with me. We have a pair of hatch marks. Put an S. We already have another pair of hatch marks. Go over it. Put an S. And there's that freebie there in the middle. 1. Put an S. So the triangles are congruent by side, side, side congruency. Don't put the little similarity sign. These aren't similar. They're congruent. The second shortcut is side angle side. Says if we have a pair of congruent sides, a squeeze angle, then sides, and the triangles are congruent. Let me give you an example. If these sides were equal, hatch mark, put an S. Sweep the angles. If these angles were congruent, we A. And then we have another pair of sides, S. Notice this angle is squeezed between 2 congruent sides. That spells side angle side congruency. So these triangles in this situation would be congruent. Let me give you an example. Down here, let's mark our freebie. Our freebie is the fact that we have bow tie angles. So hatch mark, put an A for angles. Notice what else we have. Double hatch marks. Every double hatch mark, that's a side, so we put an S. Go over the triple hatch marks. That's another side, put an S. So we see that these 2 triangles are congruent by side angle side shortcut. That's 2 down and 2 to go. There's a third one called angle side angle. Says if we have a pair of angles congruent, a squeeze side, and then another pair of angles congruent. Think of it this way. Sweep a pair of angles congruent. Put an A for angles. Now, sweep a pair of congruent sides. Put an S for a pair of sides. Now sweep another pair of congruent angles. Put an A. This side here is sandwiched between 2 angles. One angle on one side and another angle on another. I call this the hamburger. Let me get really close so you can see this. This is called the angle side angle. How do I remember this? Think of it this. You have a pair of angles, and then you have a side sandwiched between them. Take a look at this diagram. We have a pair of angles, an angle, an angle. Think of that as the hands grabbing the hamburger, and then a pair of sides. This is angle, side, angle, triangle congruency. Let me give you an example. So let's see what we have here. We have a pair of congruent angles, so sweep, put an A. Notice we have a pair of congruent sides here, hatch marks, we put an S. And then we have a freebie pair of angles, put an A. Notice the side is between the angles. This would be angle-side angle congruency. Let's do another one down here. Sweep, we have one hatch mark, one, hatch, hatch, we have a pair of angles. Double sweep and double sweep given, that's a separate pair of angles. So I put another pair of angles down here. Then we have a freebie side down the middle, that's reflexive, hatch mark, put an S. So we see that the side is between the angles, that's called angle, side, angle, similarity. Excuse me, not similarity, angle, side, angle, congruency. Do not confuse this with angle, angle, side. This is our last one. These two get mixed up, so watch very, very carefully. This last one says if you have a pair of angles, so sweep, put an A. Then if you have another pair of angles, double sweep, put another A. Then if you have a set of sides connected to one pair of angles, sweep, put an S. This spells angle, angle, side. And that means the triangles are congruent. There is no side-side angle. That is not a correct shortcut for congruency. So on the left we have the hamburger, what I call angle, side, angle. On the right, I call this the tail. So if you can visualize this, if you have a pair of angles, like a nose, another pair of angles, a rear end, and then a side, this is angle, angle, and then a side. I call that the tail. So in this diagram, let's see what we have here. We have a pair of angles, we put an A. We have vertical angles, we put another A, and then we have a pair of sides. Notice these sides is after the angles. So this spells angle, angle, side. Side angle, angle would be the exact same thing. In this diagram down below, we have a pair of angles. Hatch mark, put an A. We have another pair of angles. And then we have a side. So again, this spells angle, angle, side, or side angle, angle, which is the same thing. These are congruent. What I'd like you to do is using these four shortcuts. Side, side, side. Side, angle, side. Angle, side, angle, and angle, angle, side. I'd like you to go through here, mark the freebies, and then determine why the triangles are congruent using one of these four shortcuts. I'm going to give you 2 minutes. Let's see how you did here. Okay, first we're going to mark the freebie. And the freebie here is that we have a pair of congruent sides. And let's take a look. We have a pair of congruent angles and another pair of congruent angles. So this one is going to be angle side angle. That's called the hamburger. Angle side angle, hamburger. This one, we have a pair of congruent sides. We have a freebie side, then another pair of congruent sides, and then a third pair of congruent sides. So this shortcut is side, side, side. Down here, let's take a look at our freebie. Our freebie is we have a pair of angles, so there's a pair of angles. We have another pair of angles, and then we have a pair of sides. So this one should read angle, angle, side. I call this the tail, because it's angle, angle, and then a side. This one here, we have a pair of angles. We have another pair of angles that are congruent, and then we have the side that's sandwiched between them. This is angle, side, angle. Angle, side, angle. Not the other. Alrighty. Last four. Let's see how you did. Here we have a reflexive side, so S. We have another pair of reflexive sides, and another pair of congruent sides, another pair of congruent sides. So this one is side, side, side. Taking a look here, we have a pair of congruent sides, and we had a pair of given congruent angles, and then we had a reflexive side. So this is side angle side. Taking a look here, we have a pair of congruent sides. Here we have another pair of congruent sides, and we have the reflexive angle in between. So this is also side angle side. Taking a look at this one, we have a pair of congruent angles. We have another pair of congruent angles, and then we have a pair of congruent sides. That side is in the end, it's a tail. So that is angle, angle, side. We'll be doing more of these in class.